Positive 3 and negative 6.
So 2m squared plus 3m minus 2m minus 3 has to equal 0. Taking out the common factor, you now have another common factor. Taking that out, setting both of those equal to 0. Yes, ma'am, you want to talk to that? No, now it's fine.
Are you sure?
Yep.
Okay.
Problem number 9, it says, determine the equations of any vertical asymptotes of the graph. Vertical asymptotes means where the problem does not exist. So it goes along with number 1 that we just completed, where the denominator has to equal 0. So I don't care about the numerator, I just take the denominator, set it equal to 0. So the vertical asymptote is where x equals 1. Problem number 10 asks for you to determine any points of discontinuity in the graph. What do you think discontinuity means? Where it does not exist. So how do you think I would find if I had a problem such as x plus 5 over x squared plus 6x plus 5? What do you think I'd have to do? Okay, set the denominator equal to 0. So that means I got a quadratic. What do I do if I have a quadratic? Factor it. What two factors of 5 will add up to 6? So x plus 5, x plus 1 will equal 0. So x plus 5 equals 0, or x plus 1 equals 0. So x equals a negative 5, x equals a negative 1. So those are the 2 points of discontinuity.
I have it on my test sometimes.
Okay? All right. I'll change it. Okay, for 1, 9, and 10. Problem number 2, simplify. X squared plus 5x plus 4, x squared plus 2x plus 1 times 2x plus 2 over x plus 4. We have some things that we need to factor in order to simplify. It's not an equation, so it's not equal to anything. So I'm going to have to factor the x squared plus 5x plus 4. What does it factor into?
X plus 1, x plus 4.
What does x squared plus 2x plus 1 factor into?
X plus 1, x plus 1.
Can I factor 2x plus 2? I can take a common factor of 2 out of it, which will give me an x plus 1. Can I do anything with the x plus 4? So now I have some things that I can cancel. This x plus 4, this x plus 4. This x plus 1, this x plus 1. This x plus 1, this x plus 1. Have an answer 2. Problem number 3, a plus b over 3 divided by a squared plus b squared over 12. What do I do since it's division? So A plus B over 3 times 12 over A squared plus B squared. Can I factor A squared plus B squared? Is A squared a perfect square? Is B squared a perfect square? But it's a adding together, isn't it? It's not a subtracting. Does not factor. So the A squared plus B squared cannot factor. The only things that I can cancel is this 3, this 12. So I have 4A plus B over A squared plus B squared.
So you can only cancel the A's and the B's with the...
This is a binomial, isn't it? If I want to cancel the A and the B here, I have to have a binomial that's exactly like this. A squared plus B squared is not exactly like A plus B because of the exponents on the A's and the B's. So there's nothing else that will cancel. Okay? Problem number 4. 4c squared minus 36, 8c squared minus 24c, all over 12c plus 36, 2c squared minus 6c. This is actually a complex fraction. Since it's a complex fraction, what does it mean? That I have all of this numerator right here divided by all of this, right? So if I did the flipping and everything all in one step, have a problem that looks like this. So I need to see if I can factor since I have a lot of binomials. First one factor, 4c squared minus 36. I'd take out a 4, which means that I'd have a c squared minus 9. Does c squared minus 9 factor? Into what? C plus 3, C minus 3. This is 8C squared minus 24C factor. So I'd have 8C parentheses C minus 3.
How did you get 4C minus 9? You took out a common factor of 4 and C and 0 for C squared.
Yes, ma'am.
How many questions do you know? Like 6, I think. Okay, thank you.
4 goes into 4 once, that gives me a C squared. 4 goes into 36 9 times. So that's how I got the C squared minus 9. C squared minus 9 is the difference of two perfect squares. Factors into C plus 3, C minus 3. Happens to be a common factor of 2C over here, which will give me C minus 3. Anything that I can cancel?
C plus 3 and C plus 3, C minus 3 and C minus 3. And then reduce the 4 and the 12, cancel the 4 out and reduce the 12 to 3. And then we can cancel the 2C and the 8C to 1. 1 and 4.
And the C's are gone? So what do I have left in the numerator right now?
C minus 3.
What do I have left in the denominator?
12. 4 times
4 times 3 will give you 12. Some people still want to go through and cancel the 3 and the 12, can I?
3.
No, because this is a binomial and that's a monomial. I can't separate parts in a binomial. Problem number 5. Cn over n squared minus 9 minus 3 over n plus 3. I'm adding, subtracting fractions. What do I have to have?
Common denominator.
So if I wanted to find common denominator, I'd probably try to factor this quadratic. N squared minus 9, does it factor?
N plus 3 and minus 3.
So if I looked at that, what would be my common denominator?
N plus 3 and minus 3.
Do I have to make any changes in the numerator because these are the same as down here?
No.
So I'd have a 6n. Do I make any changes in the numerator because I only have an n plus 3 here?
No.
To what?
N minus 6.
So now I have 6n over n plus 3 and minus 3 minus 3n minus 9 over n plus 3 n minus 3. Can I do any more simplification?
Yeah.
And what would that be?
6n minus 3.
So 6n minus 3n is nothing, minus a negative 9 is positive 9. Can I take a common factor out of the 3n plus 9?
3.
By taking out that common factor, this will cancel this. I'm left with 3 over n minus 3. Problem number 6. M over m minus 5 minus 2 over 5 minus m. Again, I'm adding, subtracting fractions. What do I have to have? How close is the m minus 5 to the 5 minus m?
Very. Well, the signs are different, so you have 3 times negative 1.
I'd probably take a negative 1 out of this and I'd be left with m minus 5. So what's my common denominator?
M minus 5.
So to go from this denominator to this one, what do I have to change?
Negative 1.
So it's going to be a negative 1 times m. Going from this denominator to this denominator, what do I have to change? I think the negative 1's already here. Nothing. So now if I wanted to add these two together, I'd have a negative m minus 2 over a negative 1 times m minus 5. We generally don't like to have negative 1's down here, which means I'd have to multiply both the numerator and the denominator by -1, which will change the signs to that. Okay?